Okay, we are now recording, so welcome everyone to our weekly call. Thanks for joining, those of you that are on the call live. Quick reminder of our agenda for today. In a moment, I'll hand over to Ed Lewis from ICANN. And Ed is going to talk about DNSSEC, or more specifically, the non-deployment of DNSSEC, and I think simulated discussion on why that is and what could be done about it. So those of you that are ripe late last year will recognise the subject, or I think Ed has sort of refreshed the material, so there'll be some new material in there, and there will be a bit more time if we need it for discussion than was practical during the slot, which was part of the DNS working group session in the right meeting. Once we've done that, then as always, I'll talk about some of the recent developments in the news, remind you of some forthcoming events and some impending deadlines, etc. And time permitting at the end, we'll see if there's any other business that anyone wants to raise. So without further ado, let me stop sharing and say, Ed, formally welcome to the call. Thanks for agreeing to come on. I certainly did see the session that you did at the right meeting and really enjoyed it. So look, I'm looking forward to this. So without further ado, over to you. You can sort of share your screen should you need to. The floor is yours.
All right, thanks. I'm just making sure I have the right thing to share. I realized I had two versions of PowerPoint open because I was copying stuff back and forth, and this is going to be the one that I'm going to go with. I did send in a copy of slides earlier. I made a few slight edits, Andrew. So maybe I'll send you a copy afterwards of what I've done. So to that. Oh, let me go back. So DNSSEC Non-Deployment, what can be done? That's the title that we've that was selected. I have to tell a little story about that. I pitched this title to the right folks quite a while ago. And then over time, because my memory is kind of flaky, I prepared a completely different presentation. And then I saw the agenda and I had to go back and redo this presentation for them. So that there's different angles of this topic out there. So I actually have an agenda. I normally skip the agenda part, but I've broken this into a few pieces. A situation where we are, what's causing this discussion to be something important to me right now. Talk a little bit developers, a little bit about operators, and kind of, I think some of the dynamic is buried in there, what's going on. The missteps talks about going back in DNSSEC history about where specifically do I think we made some missteps in the design. And then recovery is going to cover a little bit about what's going on today to either get out of that or what we should go to do to get out of it. And so I'm going to go quickly. I have 27 slides. I think I'm going to try to do this a little quickly to find out what the group is really interested in. So for history perspective of this, DNSSEC was developed in the 90s mostly. But in April of 1998, we had a discussion about why is no one using DNSSEC, and that was 25 years ago. There was an effort to fix and promote DNSSEC at the time. 25 years have gone by, and the question still holds. Now, the assumption was that the operators need to be trained in this stuff. They need to get more tooling, that there's more things need to be thrown at them. It's just, they need to be given a reason to go forward. And one of the parts of the pitch was we needed a business case was being sent out there. And that's been kind of the approach for the last 25 years of promotion of DNSSEC. But I was measuring RPKI, completely different topic. And I've noticed that the deployment of that's really not going very quickly either. It's starting to pick up now, but as of my studying this, it wasn't going anywhere. So I thought, maybe the problem isn't the operators, maybe it's the protocol. Maybe we're not developing protocols that are operatable, that are operations friendly, or different terms I'm trying to use nowadays. DNSSEC isn't the only thing in this area. There's, you can name a few other deployments out there. There are things that are successful, but a lot of times things are just not rolling out there. So I thought maybe DevOps is behind this. And so I started trying to dig into that. Now, my disclaimer for these slides, this is about presenting observations and not solutions yet. I've been using this, sorry, yes? I've been using this. I thought someone had a question. Um, I've been using this deck to try to open up conversations with operators. It's been a while since I've been near an operator. I mean, I've worked for ICANN for almost a decade. Before that, I work on the periphery of operations. I've been a researcher my entire career. So I'm trying to get some more real data to support my thesis in this and maybe develop a bit of a better one. So, like I say, the deployment numbers, it's not the goal here, it's the usefulness that I'm after. So I'm looking for any input for this is what I'm trying to get. And hopefully we'll learn something along the way. Now, the divide between DevOps, I'm sure some people here are familiar with that. Developers want to maximize functionality. Operators want to avoid problems. In a nutshell, and they're two very different goals between the two of them. One of the good examples, one thing that happened at one time was a manager of a overall part of an operations house didn't want any more Swiss Army knives because his developers were giving him too many generalized tools and his operators couldn't figure out how to use them, or they were using them the wrong way. And that'll be a common theme in some of the things we see coming down the road. But one of the problems with DNSSEC was that we were developing DNSSEC, and again, I should add that my perspective here is that I was early in on DNSSEC. I wrote some of the early code. I didn't develop the protocols theory, but I did a lot of the implementation early on and was involved with the earliest specifications. At that time, we didn't have operators to talk to. The field had not existed yet. Now, DNSSEC was born in the IETF. Network security experts chimed in, DNS protocol experts. Some of them were running servers, and that counted as the operations field at the time. And DNS software implementers involved there. There were very few implementers, though, and the implementers there also were very much like protocol experts. We had a very small group of people working on this problem back then. Now, some of the other background experiences were managing cryptographic key systems, but not in the internet space, and probably more military and so on. And that really shaded or colored in how we approached cryptography and the management of cryptography, which has proven not to be how the internet does it today. Now, we had a couple of ground rules back then. DNSSEC could not change the DNS. We had to put up with what was there. And the DNS at that time was not just what was specified, but what also got snuck into code. There were a lot of undocumented features that became standard because that's the way it was. DNSSEC had to account for the fickle nature of cryptography. We didn't really know what to anticipate, so we couldn't really do a whole lot about cryptography on our end. We knew nothing about it. We just had to put a pointer into an algorithm and say, let's go with it. We had to anticipate how it would impact operations, and we did spend quite a bit of time trying to address that, obviously not successfully. DNSSEC today is the third version out there. This is just a little bit of history and perspective also. There were two previous versions of DNSSEC that rolled out. After those two, we had that 1998 meeting. There was in-lab testing increased, and the workshops, we tried to invite a dozen people at a time to play with it and try to make it more operator friendly. And by mid of 2000 decade, we have the specification we work with now as a basic. We've updated a bit since then too. We did put a lot of effort to design a protocol to be deployable. Now, switching over to the operator side of this, usually I give this talk in front of developers trying to convince us that we have to kind of change some of our emphasis. So listing on operators in this case ended up with quite a long list. In the DNS world alone, we have hosting service operators, commercial multi-tenant situations, ISP operators that do recursive service for their customers. TLDs and RIRs are major players in this, and usually are very much represented at our discussions in the standards industry. Public DNS, like Google Public DNS, for example, the 8888 service and others, they also are another important angle now that's developed. But we still have the last two, which were where we started with, which is individual operators, people who do it at home or for their relatives, and they still want to have a do-it-yourself attitude. And then there's in-house operations where a company will do the DNS for themselves, although that's becoming less prevalent as more of the hosting service providers take in that kind of work. Now, operations is its own field. It's an entire science to itself. It doesn't have to do with the internet, doesn't have to do with DNS. And I've learned a lot of operators out there are really expert in knowing how to deliver a service, no matter what it is, a black box service out there. They have all their approaches to things out there. They have concerns out there, what they do. They also tend to be experts in the service they deliver over time, especially if it's broken a lot, they have to fix it. They need to know what's going on. So operators are not oblivious to the protocol, and they know some things that are beyond the protocol that we have to keep in mind. So I'll try to summarize some of the things I think that are important here. Operators have two goals. They want to keep things running. They're given a job, keep it running. And when it breaks, get it running again quickly. Those are the two things they do. They don't always try to decide what to run, but they certainly have to keep this thing running for somebody else's benefit. They do make changes, although change is risk, but they manage that. And they have two reasons for making a change. One is it has to increase the value of what they're doing or decrease the cost of doing it. Those are the two drivers for anything out there. And that's probably where we thought business case would be the reason for this. But there are other factors in here. Keeping it running means maintenance over the long term. Operators do know that things come and go in history, and so they have to figure out how to get things going for a longer term or grow into other areas the right way. Now, the DNS field, it's only about 25 years old, which is about the same amount of time we've been deploying DNSSEC. So I don't find it surprising that the DNSSEC standards, when they came out and we've been pushing, are misaligned with where operations are today. In fact, DNS operations are still evolving. I mean, it's been 10 years since I worked for a DNS operations organization. And at that time, our concerns were things like traffic management, traffic engineering through the DNS, targeting traffic by changing the address records you gave back, and other features like that. DDoS has changed from being application attacks to something else nowadays. There are different focuses over time. It changes quite a bit. And DNSSEC is hard to operate because it was trying to cover DNS, and DNS itself is not a joyride. One other factor that is overlooked in protocol development is that operations have people working there. When you try to do 24/7 coverage, you have to have a staff. You have to hire people. People come and go, and that means training is involved. Timing of activities influenced by career retention. These are factors that come into play. Like I've been asked, for example, in DNSSEC, how often should we roll our keys? And the answer is, so long as you don't forget how to do it when people come and go. It's not a matter of the cryptography telling you when to go or what protocol needs to go. It's about people. And this is something that I think developers don't really have always kept in mind, is that we have to really key this on staffs that get turned over. And also operators, they have a wide range of environments out there. They don't all have the same situation, so we can't assume that this is the way they're going to run things. It's good to give them a instruction of how to do something, but then let them figure out how to do it in their environment. So what would make a protocol something that is easily deployable? And I'm not sure exactly yet. I'm still working on it, but a few things have been popping up that are pretty common themes. Simplicity is number one. That a simple thing to describe is easy to train people on, and when they come and go, it's not a big loss. It's also something that's hard to get wrong. If you use a screwdriver instead of a Swiss Army knife, you're less likely to use the wrong tool. You do it correctly, easily. Clarity is important too, because things do fall apart. Things don't work, and you need to figure out quickly what collapsed. What do we have to go back and fix? Debugging is a big thing. Clarity is very important when you try to debug something. I had an operator tell me complexity causes centralization. That told me a lot. And that when people don't like the centralization of the internet, they look at the protocols that are coming out there, and it's kind of driving that, because you need experts to run very complex things, and there are not many experts out there. So right now, these are sound bites. I haven't had enough time on the road to make sure that my data is full and complete, but things are coming out pretty quickly. Now back to DNSSEC, and this is part of the DNSSEC non-deployment topic for today. Is DNSSEC needed? I think the ideals of DNSSEC are pretty solid. They want you to get back the actual answers, the truth that the operator, the owner of the data wants you to see, and the whole thing. They want the whole thing to be signed together. And it sounds kind of a weird third a third goal was we had to sign our negative answers. And in DNS, going way back, it was legal in the protocol to answer back with absolutely no information, telling the querier that there's nothing to give you, and you should infer from that nothing. There's there's no answer. The problem with having nothing as an answer is that you can't sign nothing. You need data to sign a digital signature on. So in the 1990s, we came in with an understanding of the protocol. We understood what was on paper. We had some of the original developers still around with us. We also understood what was going into the code. At that time, the most important code base was the bind code. And pretty much beyond that, there was a few other implementers out there, but nothing of great significance in the field. So we could actually ask them, what did you actually implement? How did you implement it? And that became the spec. There was a solid understanding of digital signature technology. That was not new. That was applied to DNSSEC. That was used by DNSSEC, rather. And we had a solid understanding of scalable key distribution, and what it meant to get keys everywhere. And again, still it went wrong somehow. So in the next part of this presentation, I'm going to go through some of the details that have, now that I've kind of threw out the idea that, we developed DNSSEC at a time when there were no operators to really refer to, and nowadays operations have 20 years of running, and things are just not gelling right. Where did we kind of go wrong way back when? It took a while for me to figure these things out, and actually I think there's probably one more that I should add to this list, which I'll try to get to. Now, this is a summary. I'll go through these in different slides, but host security was extremely weak back then. That was probably the biggest driver in our head. That was the big elephant in our room, that we couldn't trust the machines that we were typing on because they were all weak, that operating systems were not built to be secure. Zone administrators back then ran everything. It was all mom and pop type DNS. Everyone did their own DNS. Colleges did their own DNSs. They would share with each other, but pretty much everyone had to do it themselves. End-to-end networking was still the norm. It means that when you send a packet out of your computer, it would go to router to router to router to the end unit with nothing else inspecting in between. And at the time, denial of service was a big issue. Packets of death. A machine can be taken offline, process is killed, but we didn't really have this DDoS yet. The distributed denial of service hadn't come in. And cryptography was really a mystery at the time. The code availability then wasn't what it is today. Patents were all over the place. Legal restrictions on exporting software was a big topic of the day. So let me start diving into these things. Weak host security meant that we did not want to have private keys on a computer attached to the internet. The idea was that you'd have a machine in a closet over there that would have the private key, and you would take a disk and you go there and sign the zone, and then walk the disk out of that machine over to a machine that was on the internet and load the zone. What that meant was you had to prepare all of the answers ahead of time. Every possible answer that you give on the zone had to be prepared. Now, for a positive answer, that's not too hard to do. If you have a reasonable sized zone, I could say, here are all the answers, here are the signatures. But for negative answers, that really was tricky because you can't anticipate what you're going to be asked, and then you have to say no to it. And being able to tie the denial of data to a specific query is tough without including the original query. So NSEC and NSEC3 had to approach this by saying, here's what I have. You can see I don't have what you want. And that caused all sorts of problems out there. So the question here is, what if we had online keys? And some commercial service providers have been doing this. They have their machines out there with the private keys, and they generate answers on the fly. Now, there's some up and down in the way it's been implemented. It would have to be a standardized way. We'd have to do some work around that. But we could get rid of some of the ugliness of DNSSEC by just getting rid of NSEC, NSEC3 approaches. And this could have other far-reaching implications. Now, the DNSSEC was designed assuming the zone administrators did everything. That's no longer true. There are a lot of back-end operators out there. We're starting to see that in some of the proposals to DNS rather, coming down the pipe. I think in a couple of months there's a talk about DELEG, and that might be kind of related to that issue. Another thing we had too going on was we didn't have the idea of registrars and DNS hosters at the time of DNSSEC. We didn't see the data flows, who they're going to go between. Registrars have been using something called EPP for provisioning. It's a protocol just for provisioning out there. I've often wondered what would have happened if EPP had come before DNSSEC. And I think that's on this slide here. If I had, I know the reason why we have KSK, ZSK roles. KSK and ZSK are cryptographic roles that keys take on in the management of DNSSEC. And it was created by the need to be able to change certain kinds of keys without interference or involving another organization out there. ZSK could be changed by the operator that's running the ZSK. The KSK needs an interaction with somebody else. And in our workshops, it was a pain, so we created the split. If we had EPP, we probably may have never had to do that, and we would have saved a lot of the explanation of DNSSEC over the years. Now, a secure dynamic update is another provisioning protocol that's built into the DNS. For those who don't like using EPP, secure dynamic update would be an alternative way of exchanging information. And this comes into play nowadays when we're trying to automate the key exchange between parent and child. Now, back then, end-to-end networking was under threat. The firewalls were just coming on. Middle boxes were seen as a bad thing in the internet at that time. These different devices try to impose rules on the protocol, the network out there. We've got through some of the things. We got past the 512 byte limit UDP only DNS rules that were out there, but we still have fragmentation as an issue out there. And there's still some issues with IPv6 and fragmentation in the DNS. We don't know what's going to happen with that. It works for the most part, but it could be a problem down the line. What if we went to a different DNS underlying protocol? And there's been a lot of work on that recently. Now, the threat model didn't foresee DDoS. I remember 10 years ago giving talks leading up to the idea that DNSSEC actually helped DDoS because we had larger response sizes. The amplification attacks were helped by DNS. We also had a lot of capacity to deal with all the traffic, so we became even better, more of a help to the DDoS folks. What would happen if we were concerned by response size back then? We have to go back and look at some of our assumptions about this. We didn't really think about large responses as an issue, but today that's probably the biggest issue when it comes to some of the key management issues we have, especially with the root zone right now. Post-quantum, we might not be able to limit the size limits. Post-quantum could be, we don't know what to do with that yet. That could be a larger keys and signatures required then, and that could become a concern again. So code availability, cryptography. I have to admit, giving the talk over Zoom, I can't see my own slide titles, so I'm not sure what my topic is at each slide. But code availability, we didn't have OpenSSL back then. We didn't even know what people would have. So we didn't assume in the protocol that everyone would have all the protocols out there. That's not true today. Pretty much every implementation has a common cryptographic library that they can refer to. And a lot of protocols are widespread and pretty common. Hardware security modules, they didn't exist back then, at least not in the DNS world. And I've seen, as they came in, they caused quite a bit of a challenge for operators because while they were good for DNSSEC in separation of keys and the internet, redundancy and reliability became an issue when you realized you don't want a single point of failure anywhere. And with the protocol, DNS didn't quite, DNSSEC could have probably done a better job of handling some of the reliability around those machines. We had patent issues with algorithms. At the time, RSA algorithm was still under patent control. DSA was all we had. So a lot of our initial testing, we didn't have a second algorithm to even know what was going to happen in a key role. And when we changed the algorithm out there. And of course, we had legal restrictions back then. I remember we had a big party when Bind got an export license to be able to send copies of Bind with cryptography libraries in it across borders at one point. So what if we knew more about having multiple DSA key algorithms at once? We probably would have tweaked the protocol a little more back then. And the whole idea of changing from one to the other was not really touched on by any of the by our initial protocols. Sorry. Now what if we knew that we have a basket of widely known, commonly available algorithms? We don't have that right now. And what if we knew operators would go simple? And this is probably the biggest thing out there. Most operators only use one algorithm. We had thought back then, the operators would use different algorithms for different purposes out there. We thought they'd pick and choose the cryptography more carefully, depending on the strength of what mattered. That hasn't happened. Operators go simple with just one at a time. And that's been a big difference. So to improve the deployment of DNSSEC, we need to address the operator needs out there. And these are a couple of things that I think have come up in different discussions I've heard. Child zone, parent zone tying, the provisioning between the two of them, that's where we've tried to be able to get keys from the child up to the parent in a correct way. That's been a big issue. I know that I work for an organization which we implemented ZSK roles pretty quickly for our potential customers using DNSSEC. But KSK, we just decided, we just couldn't figure out a way to do that. It was too manual to come up with a good solution for that. Multiple backend provider. There are a lot of large organizations out there that make use of more than one provider out there. And they want to have a much smoother interface in doing that. On the other hand, when I worked for one provider, we recognized that we switched customers with another set of providers, and it would have been better if they just made it easier to transition in and out of us. There wasn't much competition there to fend off. It was everyone was gaining and losing customers at the time. We need to ease the way we switch cryptographic algorithms. If anything gets stuck, if someone's using a cryptographic algorithm that's obsolete, that's bad. We need to be able to get the new stuff out there. We need to get new stuff rolled out there in general use. We need to avoid the potential mistakes, and that's where that's a very large task to do. But there are so many places where we have too many knobs, too many dials, too many things in the Swiss Army knife of DNSSEC that lets people use it the wrong way or configure it the wrong way and get in trouble. And finally, better debugging support. It's very hard to find problems in DNSSEC, usually ahead of time even. There have been a lot of operators that rolled out zones that were improperly signed because it was just hard to find out what happened. There have been some mysterious bugs out there where in some cases signatures were malformed, and the public reports and even the internal reports never really addressed the exact issue out there. So we're not able to stamp out all of the issues ahead of time. We need to be able to detect them ahead of time. Now, we just need to have a simpler to operate protocol, and that's the new staff issue I mentioned earlier. Now, what do we need different ways to get there? We didn't know where to go. I mean, I don't have a notion of requirements. This is one thing I'd like to talk to operators about, is to get, what is it that they really want out of the protocol to make it go forward? And then there's been a lot of work in the IETF to tweak the current records to handle new assumptions. And this is a technique where you take an existing protocol, an existing record rather, which is already supported in software everywhere, and just change what some of the fields mean. And there's the idea that this means we'll get things rolled out more quickly because the code already parses this stuff. However, when you start changing the meaning of fields and you're trying to debug things, you have to start thinking, was it in this value in this field, was it meant to be the old way or the new way? It can be confusing. Another way to start cleaner is to create new records and suffer the need to roll out software and new code paths, but you're going to have to roll out code anyway, whether it's an interpretation of an existing field or a new parser out there. I don't think parsing is the hardest part of DNSSEC or DNS processing. Now in the ITF, they have requests for comments. They have basically specifications that are guides for software developers out there. And the ITF prides itself on the idea that a specification should generate more than one interoperable implementations out there. What's missing from this is the operational guides, the operational profiles, which say here, that's a good protocol and here are all the parameters, but pick these ones, describing the default settings, what's the best way to do things, what's the best, what are the specific best ways, best practices, basically, when you're running the implementations out there. And it would be good if the success of these protocols would look at the deployment, not just implementations, but look at actually getting to be used out there. Now, so perhaps there's a need for an operational series for the DNSSEC and other parts of the DNS. And that's my last prepared slide. And hopefully there is going to be some discussion and questions on this, because I'm not giving you a prescription for fixing things, but hopefully making you think about, what is it, what what would help you if you're an operator to see DNSSEC be easier to deploy? And on the other hand, what do you think we need to fill in? And how can we make things simpler and not more complex? Oh, and I should probably end up with the Brett Huber, if I'm saying his name correctly, and the DNS Camel presentation he gave years ago, where he said, we've already piled on so much of DNS. Let's not add one more straw and break it. I realize that every time you change something, you're risking it, the camel, but sometimes you need to do something to simplify too. And with that, Andrew.
Fantastic. Thank you, Ed, for that. So you covered a lot of ground there. It's a good historical context. Just for clarity, and I can see a question in the chat, plus I'll open up for questions from the floor. Are you advocating for a new, an updated RFC for a new version, streamlined version, perhaps of DNSSEC, possibly combined with some operational profiles, or do you think there's something else that might help to kickstart sort of further deployment? What's your current perspective on that?
Well, I think the first thing is to decide to have we need to know where to go. We need to have a goal here. And so what I'm trying to do is get operators to speak up and say, here's what I think needs to be done in the protocol. And I've had a few of that. I've had a couple of discussions after. Usually when I give this talk afterwards, I'll be caught in a hallway with an operator and some great idea they have. We need to first get to an idea of what really needs to go into the protocol. The operators really need to have a voice heard in this. They have a lot to say with this. It's unfortunate that it seems like most operators do not participate in the IETF discussions. That's a long-term, and I brought this up internally with some of my colleagues, and they said, why don't the operators just show up? I said, well, they just don't. And that's a case where we need to figure out how to bridge that communication gap to get out of the operators. What do you really want out of this? What I see eventually is targeting some new types out there, new ways to do some of the stuff out here, like NSEC 3, we could do better with negative answers. But it's going to take a commitment for folks to say, we really want to get that. And I guess I should also say that I think the way that we promote and fund, in some sense, this new development work is through the anger or the angst of the operators who are suffering the pain of running it as it is today. Can they reduce the cost of DNSSEC operations by having something easier to run? And I think that would be the impetus to make any changes here. So right now I could see coming up with a better plan, documenting that, but also realizing that we do need to have operational profiles. For example, there are some that are in the RDAP world that we'll see how they go.
Yeah, fair enough. And to be fair, I think the lack of operational insight and input into the ITF is not unique to the DNS, to be honest, having had similar conversations in the security arena as well. But anyway, okay, I'll take these hopefully in the order that they appeared. So firstly, I'll go to the chat for a comment from Josh, and then I'll come to Ross, and then go back to the chat for some additional comments in there, and then we'll see where that gets us. So Josh's comment in the chat first. One of the things I struggle with when talking to DNS operators or decision makers is having a good answer to the question, what's in it for me? When I enable validation, what am I getting? When I sign a zone, what benefits am I getting? This is difficult to explain and to quantify.
Right. Yeah, I'll sort of elaborate a little bit more on that. Right. I know I see a lot of the presentation. Just great, provides a very good background on where DNSSEC came from, what were some of the design principles. And I see a lot of focus on how do we make this easier for the operator, which is a good train of thought. But I think, at least from my experience, the difficult part is convincing them they even need this technology. Well, one, I got to explain what it does. And ultimately, they're going to ask, okay, if I'm going to go through all this hard work to enable it, to do zone signing, to deal with registrar and key rolling, what do I get out of it? What's my return of investment? And I think the folks on this call you know, we get it. And I think even a lot of us have a hard time to say, yes, you'll be safer. It's more of a, truthfully, yeah, you help other people to be a little safer if they also did their part. And that part usually kind of falls a little flat. And at least it's difficult to explain. And like, say, encrypted DNS, that's very easy to explain, and that's a whole different can. But so that's kind of where I'm at, is how do we have a good, clear message to say, this is why you need this technology. And even then, if it's not easy to deploy or easy to operate, once we can convince them this is something good, then people are more willing to give it a try, even if it's less intuitive.
Yeah. Okay, so yeah, I'll tell you, if there was a good, clear answer for that, we wouldn't be asking this question for so many years. But let me try. In some of my deep background in working in this, we had this idea of a trusted computing bases out there. And the idea was that you want to build in security at the core level, at your foundational level of whatever you build. So with DNSSEC, the idea is that if we can make sure that the answers travel through the system and without being modified, you as the publisher of the data are pretty much assured that the receiver will get what you said out there. And you can say, well, you know, it's important that I get my message across, and we take that for granted. But the first question is, well, what if I already have TLS out there? What if TLS is going to protect me because someone sends me to the wrong address, but I get there and the keys get dropped over there? Well, you know, that's a good point, frankly. And I don't have a shutdown response to that, except that you had to go to the effort of now going to this other spot and finding out you didn't want to go there. The question is, do I ever get to where I want to go? So if the DNSSEC is trying to make sure that we only cache the appropriate data out there. And so if people come back into the answer again, they come back and ask the question again, the same recursive solver, they will know that they're going to the right place in the first place, not getting misled every individual one out there. We're cutting down some of that slop out there. Now I've been making the mistake of using the analogy of seatbelts for DNSSEC. You know, that they're something that'll save your life in an accident, but we never buy a car because of it. And I was pointing out to someone, says, yeah, that's true, but I don't think that he didn't think DNSSEC really was that level of security because I have TLS. And I go back to thinking now that, you know, the seatbelts, TLS is kind of like airbags, and seatbelts are the DNSSEC, and you need both really to keep yourself safe in a vehicle. Again, using analogies, I know it's not a really good response, but that's kind of what I'm drawn to out there. It comes down to, you know, the idea that if I can secure each base, each level of my technology, I'm going to be better off. And that may not be a selling point, unfortunately. But there's also the other factor is that not everything uses TLS. And that's where the factor comes in. What if I'm going to connect to something where I'm not going to be making a TLS connection? I'm doing something else, some other protocol out there. That's another reason out there. Again, I don't think any of what I'm saying right now is new or a shutdown answer to this thing, but it's kind of getting to the point where DNSSEC gives you a marginal amount of benefit here. And maybe the margin, you know, isn't enough to justify the cost. And that's why I'm talking about making it operator friendly. But that's kind of where it's going. I mean, DNSSEC does achieve goals that you want to do, but it may be masked by other solutions, other mitigations higher up in the stack. But that works only if you're using that part of the stack. So,
well,
I mean,
sorry to interject there, Ed. To that point, a comment in the chat, which I think is pertinent to that, is the fundamental problem is that when DNS works, it does its job silently. Virtually no one knows that they're being protected. But when it fails with key exploration, etc., it fails spectacularly, and the whole validating world loses the ability to reach you. And that's not a great failure model. And I do know that some of the browser manufacturers, for example, are very reluctant with DNSSEC for that reason. That the failure, the risk of failure and bad user experience, in their eyes, is not worth the cost. So so I think looking at the ROI, that needs work to get people to buy in.
Yeah, I chip in there. That's where I talk about debugging. Right now with DNSSEC, going back in history, we only had one field to send back an error. We sent back serve fail. Everything was serve fail. In DNSSEC validation, you can tell why things are not working, and you can pass that back. I think that would be one way we could address that, is to make that a little clearer. And also, and there are a few other, like where do you report errors and so on. There is some ideas of what's out there, but we really haven't pursued them hard enough.
Yeah. Yeah. Okay, right. Let's go to Ross. Then I've got some more comments in the chat, and then Kathleen and Ralph. And then I think we'll probably draw a line there, estimating times and so on. Ross, even, you've been waiting patiently. Do you want to come in?
Yeah, thank you very much. So thank you for your presentation. I really appreciate that you recognized and pointed out the lack of operator from like an enterprise perspective participating in this whole process. Having been an operator for many years for a large financial, although I'm not in that role now, I do work with operators in that context basically all the time. So I'm happy to talk to you about that and try to provide you perspectives from that side of the house if you want. But I would say, a few things that I would say about the issues that they run into. You noted it a little bit in that they don't get to decide, right? The person that's actually operating the DNS doesn't get to decide whether they make the changes. And most of them that quote unquote decide to sign didn't decide to sign. They were forced to by their auditors in most cases these days. So that's the continuing deployment of it is actually being forced more by auditors than it is the actual enterprise operators. They're being told by their auditors, hey, you have to deploy this. As far as issues that they run into that I don't think were accounted for in your discussion, how do you deal with GSLB? How do you deal with a multiple valid answer, but it's only going to be given dependent upon somebody's geographic location? So in other words, if I'm coming from Europe, I'm going to get one answer. If I'm coming from the US, I'm going to get another. Very common, very much not accounted for in DNSSEC as to how to sign all those potential answers without doing dynamic real-time signing, which is very computationally expensive. And in addition to that, going into the negative side of it, is there really a need to sign the negative answer, or can you just say an NX domain is okay as long as it comes from a properly signed SOA? So just avoid the whole signing of negative answers, which should hopefully save a great deal of pain that's involved there.
Okay, so should I respond now, or do you want to keep going? I'm sorry.
Oh yeah, go right ahead.
So the first one about the multiple answers. I worked for a company that was a specialty, and I understand the pain of that. I call it traffic engineering. The traffic engineering of DNS. You have to sign every possible thing out there and have a huge database that decides when to give which one out there. And then again, things get confusing. We had customer complaints when they thought it wasn't working, when it was working, and so on. It was really comical to deal with. Let's see. And the second, I'm sorry, freshman. The last comment you made? My mind is not what it used to be. But
sure, yeah, I threw a lot at you. I should have broken them up. But why do we need to sign negative answers, right?
Oh,
and it's not because I think that negative answers aren't important. I know that they are important, but since that's a huge piece of the pain, can we say that a properly signed SOA that's providing an NX domain is sufficient to try to, in a simplification type of approach?
I had this same discussion with someone maybe 20 years ago in DC. Unfortunately, in DNSSEC, we have to sign the negative answers because of the way we do delegation information. We have the DS record as you climb down the tree. And if I ask for the DS record for going down to a child zone, if that's not a secured answer, I can't trust whether the child is going to be secured or not. So in some sense, for the protocol's essence, we have to sign the negative answers. Now, on the other hand, I do remember that this issue, though, is something that's been hanging around the protocol for 20-something years, 20 plus years. And yeah, I think that signing negative answers would be a lot easier if we did online signing, but that wasn't an option when we designed this, and make it be easier. But yeah, there's always, yeah, if the concern was, what if someone can lie about something not existing? And I think that's where that came from. And to be honest, for completely honest here, the whole NSEC 3 approach was done before I entered the room to know what discussions were. So I can't give you the total motivation for this, but that's kind of where, I think that the protocol needs it because of DS record. Maybe it's an exception, but yeah, some people can go back and try to figure out either an easier way to do that or whether it's really needed at all.
Yeah, I'm more than happy to participate in that. So, reach out to me or we can connect, and I'm happy to discuss this with you at length and provide the enterprise operator's perspective at least.
Sure. Appreciate that.
Brilliant. Right, well, I'll synthesize a couple of comments from the chat, then hand over to Kathleen and Ralph, because I know Ralph certainly's got a hard stop, so we'll cover those. So making a positive from a negative, I think if key trap means that there needs to be an update to some of the DNSSEC RFCs, maybe there's an opportunity to do something in this sort of general area as well, do some sort of housekeeping at the same time. I think covers off a handful of the chat comments. But Kathleen and Ralph, let's get you in, and then we'll see how we're doing for time. I might need to take some of the other chat comments offline and perhaps share them with Ed. We can handle those separately. But Kathleen first, then Ralph.
Thank you. So I appreciate the presentation and discussion, and do recognize and have also seen the challenges mentioned in terms of getting operators to participate, and also the gap and the struggle on the IETF side, in that if you go once, your voice can be lost, right? And you have to keep showing up. And the model is that you're representing yourself as an individual. So the force of many operators really can't be felt, unfortunately, because of how the model is set up. Maybe this is all obvious. Now, I'd say Arnaud has done a fabulous job, like as much as he could, trying to represent other people who are operators in the security area. So perhaps that's what's needed, is, somebody like him that continually goes out and collects the thoughts and the feedback and the input, and then continues to represent that. But again, in the IETF view, he's viewed as one person, right? And so it's tricky. I'm, speaking out loud because maybe there's a way to change the model, right? Because it's kind of broken. We want operators to participate, but the barrier is too high. They can't fit it in their workday. So putting that out, food for thought. I don't have any answers, but
yeah. Sorry, go ahead.
So yeah, I mean, I think again, if we knew how to fix that, we'd be addressing it. But yeah, I same observations. Everything you said there is spot on.
Yeah, maybe that's a rhetorical question for debate over a beer for those of us that are in Brisbane. It's always a rich vein for several beers, probably over several evenings.
Yeah, and people to think about it, right? Because maybe somebody will come up with something.
Yeah.
Thank you.
And as you said, it's not just a problem for DNS, to be fair, it's the model generally, how to get more of an operator or operational perspective on the stuff that the IETF is doing.
Yeah.
Okay, Ralph. Sorry, Ed.
Just from my end, what I try to do is I try to reach out. I try to go to operator fora and have conversations and hallway conversations when I can. That's about as much as I've at least tried to collect the stories, and then see if that can help at it. That's the best I can do.
Yeah. Okay. Thanks for that, Kathleen. That's I think a very valid observation. Ralph, did you want to come in?
Yeah, so on the kind of value of DNSSEC, I mean, Ed put that out, but I've been operating DNS for now 30 plus years or so. And I've been unfortunately once or twice in a situation where I had to explain pretty much a cache poisoning and the possible commercial impact of that to someone who was a customer of mine. And once you're through that, DNSSEC becomes a no-brainer. I mean, gives you a data authenticity from kind of the input, which in some cases might be your own company, to the output, which again might be the result in your own company. So I think explaining these authentities, and Angel, that no other protocol gives you, I mean, for me, it's a no-brainer.
Yeah.
Maybe, I think one of the things, Ed, you said earlier, perhaps bringing some of the compliance people and regulators into the discussion might be quite helpful to provide the focus.
Yeah, being mindful of time, I'm going to keep, I'll try to say quickly some thoughts I would elaborate on. The reason why you set up seatbelts as an example for DNSSEC is that seatbelts came along after a bunch of government pressure to have them installed due to car liability issues in the United States. And then seatbelt use came much later on with more ticketing more recently. So sometimes you need to have regulatory pressure to apply these things. Now, in terms of the cache poisoning examples, that's what DNSSEC, that was our original use case. And we've tried to convince people that cache poisoning was a reason to do DNSSEC, but usually you don't see cache poisoning happen all that often. And at the time I was doing DNSSEC research, was for a small company that was a labs somewhere. And we had some people who would say that if there was really a really good attack and took people down doing this stuff, they proved I was right. And I thought that's a sad way to go around in life. So I've tried not to tell people that, all I need is one person to do a cache poisoning attack and you'd see DNSSEC's brilliance. It's got to be another way to sell it. But you're right. It's showing its value is hard for folks. So.
Brilliant. Well, let's draw a line there. As a tongue-in-cheek comment, I can see that the first ambassador for DNS abuse is taking his job title a bit too literally and seems to be advocating for a cache poisoning attack to focus minds. But I'm sure I've misread his comment. So you should never give someone the title of DNS abuse ambassador if you don't want them to advocate for more DNS abuse. That's maybe where first.
Andrew, this is it. Gross misrepresentation, Andrew. It's not true in any at all.
Teach me for reading it too quickly. I do apologise. Right, just to wrap up, let me just very briefly share my screen for just 2 minutes. So thank you, Ed, for that first. That was really excellent, as I knew it would be. I'm not going to go through the news headlines because we don't have time. Those of you on the mailing list will have them, and I'll include these with a link to the recording for those of you not on the mailing list. And if you want to be on the mailing list for these, drop me a line and I'll add you. But I have to say, Mark McFadden gets the prize for best pun this week on Deleg. You can see the bottom of the screen there on without a leg to stand on, making the case for the DNS camel, amongst other things, but as our time doesn't permit us to run through these in detail. The ECH encrypted client hello draft is now making progress. We'll probably move to working group last call just before the cutoff for the next IETF meeting. And the agenda for the Brisbane meeting is now out, and we'll spend some time on this call in a couple of weeks, just sort of walking through some of the sort of highlights of that, just to signpost those for those of you that are either attending in person or remotely. There's a whole bunch of other stuff that's happened in the world, which again, don't have time for, but I'll share these afterwards. Few deadlines coming up this week. So there's a WSIS questionnaire closes in a few days' time for those of you on the policy side. Likewise, the Internet We Want questionnaire also closes in a few days' time, and then the Centre Jamboree call for proposals, and there's a funding opportunity as well for cybersecurity academic startups. So those are all coming up in the next week or so, if those are of interest to you. In terms of events, if you if you were planning to go to the DNS Community Day at Apricot, you've missed it because that's already happened today because of time zone differences in Bangkok. But from what I could see, there are about 25 or so people there with the OARC team. There's other stuff coming up, but again, time doesn't permit us. And then finally, this time next week, Carolina will join us from the DNS Research Federation to talk about their Internet Standards Tracker. We're very much focused on the IETF standards in particular. So just advance a reminder of that this time next week. So with that, I'll stop sharing. We're pretty much out of time, but I just pause. In terms of the comments in the chat, I'll share those afterwards and see if there's anything else to pick up and to respond to. So thank you for everyone for commenting. Thank you again, Ed, for the presentation and discussion, which I knew would provoke a discussion. So no great surprise there. And yeah, I'm only sorry we didn't have even more time. I could probably done with double the time and still wouldn't have finished. It's an important topic and it needs more focus. So let's hope it starts the conversation. And as Josh said, the strap line for DNS ops going forward, the DNS is no joyride is an excellent, if not very positive, selling point for people getting involved in DNS. So yeah, I think that's a good one to leave us with, Ed, from your presentation. So thank you for that. And with that, we'll close the call there as we are a minute over. Have a fantastic week, everyone, and look forward to an interesting talk with Caroline at the same time next week. So see you all then. Bye, everyone.